All right, let's get right into this morning. So my name is Scott Champagne, and this is the Professional Linux Users Group, Linux Security Engineering Unit 6. We are recording the session today. We did the session last night with everybody, and then today I'm going to record it. It took us about an hour and 40 minutes yesterday to get through everything, so I'm hoping I can get through it pretty quick today, but trying to still hit all the salient points for you guys. So here's our announcements. We're in our 6th class meeting. If you had any questions, ask them down in Discord. And then we're going to have an event coming up here in August, so you guys can go check that out down the Discord if you want to do that. All right. So what did we do last week? A little bit of a review, a little bit of kind of absorbing everything together if you did the course last week. We talked about building repos and enterprise patching, and we talked about that in the context of the week before, which had been to put together Bastion hosts on air-gapped systems. So part of building repos is having the control over what can be deployed to your systems and what your systems can download and install on themselves, right? Because no matter how you configure the repos within a box, if you don't have the ability to go out anywhere else, there's no danger. And then if you do want to be able to update software, you can point it to your own repository. So you have this like modicum of control as a systems engineer and systems administrator. So then we talked about enterprise patching and some of the challenges that came with that, and then we did our worksheet in our lab for last week. So that was last week's stuff. The general review then is control and what is fit for use and fit for warranty, and how do those work in with those topics. How did we create, or why did we create a repo locally? To be able to still update and patch things and add software to our environment, but then not let it just be whatever version of whatever's out there in the world, and then we have thousands of different versions of whatever packages that we're downloading off of a repo, because we don't control external repos, right? Like I don't control Red Hat repos. I don't control any repos out there. I can download them and have them hard coded internally, and then they can be life cycled through, which is that last concept we talked about. How did we create a repo? We did a local one via file. Shared off of a mounted ISO on the network, and then we also shared our repo over the network with HTTP, right? We used HTTPD daemon. We wrote a few directives for us to be able to share out the resources and all that kind of stuff. How do we configure our repos on our local machine? We got rid of all the old repos, and then we used etc yum.repos.d. There's all the repos files in there, and we made our own repos to point either locally or at the network. That's what we did last week in the lab. All right. And then we talked about what's enterprise patching different than just one-off patching, pushing update on your phone or on your laptop or whatever. Well, that's just a one-off system, and you're just going to monitor and hope it comes back up, and hopefully there was some testing. But enterprise patching, we may be doing 1,000 systems one night. We might have all the dev environments coming in, and we don't know the state of the machines as they come in, and we don't know what's been done on them, and we don't know that they're all pointed at the right repos. So typically when we do that patching, and I provided a playbook, and we used a lab where we went through and we did a whole bunch of pre-checks before we even got into the patching. Then we did the patching, and then we did a bunch of application validation after to make sure that the server was up at the right level, and then to make sure that the app was up at the right level. So those are all things that we did last week, and that's a last of our little review there. So then this week, we're talking about logs, right? What are logs? Why do we care about them? How does it fit into like a security engineer's ideal? Obviously, we have the STIGs, right? Those STIGs that we've been working with, the Secure Technical Implementation Guidelines, and we're saying, okay, within the STIGs, there's all these rules about what has to be done with logs and all that kind of stuff. But we're going to start out with like, what are logs? How do we get them? How do we aggregate them? Where do we put them? All this kind of stuff. There's different architectures and archetypes that are common across all systems for how we gather logs. Then once we've gathered the logs, what do we do with them? Well, we want to parse them out. We want to look through them for patterns and look through them for indicators of previous, and we're going to get into this a little bit, but previous things that have happened, and then also future indicators of things that could occur, right? That's true. There's like this model of data usability, right? And logs have all kind of useful data in them if you're good at getting in the data and looking at it, right? Seeing what the data are trying to tell us. Then we got a worksheet for this week, and then we have a lab for this week. And the lab will probably take the most time of all this stuff, so we'll get down to it. So here's our overview of what I'm going to talk about. What is a log? It's an immutable record of an action that occurred or tried to occur, right? Even the attempt to do something should be recorded. Like somebody walking by and attempting to open the front door of your house should probably be recorded, even if they didn't get in. Even if they weren't successful in whatever they did, we should still track it, right? And then how do we do logs, or how do we use logs? We use them for a bunch of different security incidents and formulating responses to incidents that are happening in our system, all kinds of things. We'll look at that. We'll talk about the common log elements. Like if we agree that a log is an immutable event, right? We agree that it's this line in a log file, right? But it's this event that happened. Well, there's probably some things that should be there, like when did it happen? What's the severity of it? If we might not know what the severity is, but what does the system think the severity is? What process or process ID was kind of using it, and then what the general message was, something short that could help us to, find maybe and go dig in more on that time frame, right? So we'll talk about the common log elements. They're very well structured. There's a few different RFCs for them, and then there's kind of an emerging one, but it's used really just within the system. Then we'll talk about where we store logs. Like if we have logs on a system, are we rotating them for space and compression and all that kind of thing to be able to allow them not to impede the function of a single machine? And then how do we get off it? I was telling the guys yesterday, like I should have taken this line right here, get logs off servers in real time, and that should have just been plastered on the front of this page, because that is probably the most important of all the things that we're talking about with logs. Is you have to get them off the server in real time. You eliminate a whole bunch of offensive strategies of people if you're getting logs off in real time, and especially how people clean up their tracks in a system. They have to delete the logs. Well, even if they delete the logs in real time, what they're doing is already being sent off, right? So that's huge. The attempt of them to even connect into your machine was already logged, right? So get logs off the server in real time. And then the other huge part of that is, well, if the server goes down or a fleet of your servers go down, you have to wait until they come back up to get at the logs. That's terrible. That's like easily one of the worst things I can think of in engineering. Like, okay, a fleet, like we have 30 servers go down, and I have to wait until we get it back up to find out if it was something malicious and something that's going to spread to the rest of our network. And, oh, we should have brought those up, quarantined off. That's a terrible time to find that out. You should already have been parsing through the logs of those systems, like the last things that were sent off, right? I think of this like, if you ever look at like any of these, any of the alien movies, any of these things, they come to a deserted spaceship and everybody's dead, and they have to go all the way into the middle of the spaceship to read the logs of what happened. Well, now you're all dead, right? Now that's why we got a movie, is because you guys had to go read the logs. Instead of just being able to scan it from the outside and go, oh shit, something killed everybody in this ship, we probably shouldn't even go in there, right? Anyways, get the logs off your servers in real time. And then how do we parse and look at specific information from logs? Like how do we look at them? Well, on a local machine, we can do command line. There's a bunch of command line tools. We can cat and grep and set and awk, and we're going to look at kind of that hierarchy. And then we're going to use specific tools to kind of do that. Now, we don't dig super far down into that in this course because we just don't have enough time, but you'll see me do that over time. And then if you guys want to talk about it, just let me know down in the Discord. All right. So let's get into a little bit of the log usage. We review logs. We do troubleshooting and security auditing. So troubleshooting, something went bad. The server crashed into a wall in the data center, and you're like, how'd the server crash into that wall? Well, we find that the server started to accelerate. Okay, maybe I'm being a little silly, but the point is we can troubleshoot. There was an acceleration over time of errors of I/O to disks. Some of you guys in your career, some of you that are kind of newer, you may never deal with spinning disks. You may always be dealing with these super fast SSDs and all these other things that have no moving parts in them. But I can tell you, when you used to have moving parts and spinning disks, and there's still a lot of spinning disks in data centers, don't get me wrong. But when we had a lot of spinning disks, one of the last things that happens before the head crashes into the platter of a spinning disk is you start to get a lot of I/O faults and errors and retries of transmit. So if you ever go and forensically, or if you've ever had to troubleshoot a crash of a server or crash of a disk, you always see the logging of errors against that disk start to slowly go up. You also start to see a degradation of performance, of latency against that disk. This is, I'm not telling, look, anybody that's been around knows oh yeah, that's exactly what happens. As a spinning disk fails, it doesn't typically crash right away. It's like some skipping and it takes some time. And, it's doing 6,400 or 7,200 RPMs, rotations per minute. So like over the course of a day, that's, many millions, tens of millions even. But it's, it still slowly has these events that fill up. So we can troubleshoot what happened. Like, oh, hey, and then we can use that to make sure that it doesn't happen again. We can do security auditing. What I was saying earlier about logs that track user activities. You guys know I track everything that tries to come into my home lab. I have a Bastion server that sits out there that all of you can connect into for the course. But then I also have, right? I also have the ability to see all the people that just knock on the door and try to SSH in. And if they attempt a password, it pops in, right? And you guys can see that. I'm not going to pull that up right now, but in the normal day-to-day when I'm streaming, you guys can see that. And then we can also do checkpointing. We can do performance monitoring. So how well is something working? It didn't crash. Something didn't crash in this case, but how close did it get to crashing? Peaks and valleys. And in engineering, we talk about upper control and lower control limits of an event or a process that's occurring, right? We can do performance monitoring. We can say, how well did it do the thing that accomplished correctly, right? Not just up here where something failed to cycle completely, but down here it actually, did whatever. It worked, but what's the performance of it? How could we find that next thing that could be done a little better, right? We find that our app does what it should, but when it's making an API call out, that's what we always call the long pole in the tent. That's the thing that's going to take the longest time, or in production, it's like critical path, like what's taking the longest time. And that's where we focus our time on, right? And then also for debugging, if you're writing applications and you want to send out stuff to a log, you can keep these application-specific logs we have there's 4 big ones, and we'll look at them here in a little bit. 4 big things that apps really should be doing, like latency and all these kind of things. So we'll look at that. So that's kind of like what logs are for, and we're going to get into that as we touch each piece. So here's our log elements. I said that if we're going to agree that logs are valuable and immutable and whatever, they should be in a format that everybody understands. So the common log formats are in RFCs 3164 for BSD syslog and RFC 5428 for IETF syslog, right? And that's what Berkeley Secure, Berkeley Standard Distribution. I always forget what the S is, but that's the Berkeley distribution that all the versions of that type of Linux came off of, and then the Internet Engineering Task Force syslog, right? Logs must be timestamped. Commonly, we use the ISO 8601. We use that for IETF. Syslog, you're going to see a little bit different standard, and also even though it's timestamped, the BSD tends to not have the year, right? They don't tend to have the year on theirs. Logs must be categorized by severity. It allows for proper routing. If I tag the type of severity of my routes, and also there's kind of almost like a class as well, then we can send them to different files, right? And common Linux systems are debug, info, notice, warn, error, crit, alert, and emergency. Those are the common ones that you're going to run into. So we'll kind of see that throughout the labs and stuff that we're going to do today. All right. So here's a 3164 BSD, and the timestamp kind of looks like this: October 26th. It's got a time. Look, again, there's no year. We don't see any year, but I could determine that it was October 26th here. It says the host name typically, and then and that's because sometimes we aggregate these up. Very often we aggregate these up. We're going to look at that here in a little bit. And then we know the process ID and the process that's doing it. So process and process ID, which could, if we're dumping like a kernel or a stack trace of different processes, this could be useful for finding the process ID if it's not mapped in any other way than the PID. And then it gives us a little message: accepted password for user 1 from some IP address, right? And that's just whatever is defined as a message inside of that tool. And it's useful for people who are useful or used to looking at like SSHD, right? So that's kind of the older format. This is what a lot of Linux logs are in. You're going to see this a lot. And then IETF is kind of a newer format, and it looks like this down at the bottom. And the differences here are this is stamped to the exact day, and it's using the ISO. This is the ISO 8601 format. So if any of you are here and you're like, oh yeah, I program and I do API calls and stuff a lot, this is like probably your life right here. You're dealing with the actual ISO 8601 timestamp. That's what we use a lot in Ansible. We pull our facts out of systems there. And other than that, it's very similar as far as the output. And here's some of the things that might be kind of interesting to you there. But other than that, it's pretty similar, but the timestamps are totally different. And when you're parsing them or doing searches and filtering on them, you just got to remember that they're going to be slightly different. All right, good. So we get to the other one. I mentioned that there's a more modern one, but the thing about systemd journal, while it gives us some useful stuff, I want to point out these two are kept in plain text. This one is kept in a binary format. So you can't cat this file. You can't cat a systemd file. You can't do it. It doesn't, well, okay, you can cat the file out, but it's just a mess because it's kept in binary. So it's more compressed that way, right? It's natively smaller when they do it in binary format. And then here's the things that you can get out of there. And you typically view it with, like, in Red Hat Systems Journal CTLD, and then you can see kind of what's going on, right? Okay, so systemd we won't spend a lot of time with, and we won't actually worry about collecting these, because I found in my career most of the time systemd is kind of just like stuff that's happening inside of your server. So it's not, I've never really seen this be collected as part of logs as far as what's going on here. These two, we're always collecting these type of logs, so that's what we're going to do a good part of this. All right, so now that we know what logs are, hopefully you guys can hear that. A log.
What I mean is, suppose you set your heart on somebody.
On a log.
What would you do to get him?
The log.
Grab him and take him.
Take the log.
You grab him and take him.
Take him. Like that.
Take it. Grab the log. You just take the log. All right. So, logs and rotations. Real quick, other thing about logs. Log rotation is a very important part of this. We don't do it in the labs, but I do highly recommend you go look at etclogrotate.d and etclogrotate.conf to see how the logs are occurring inside of your system. So if I pull up like my home lab system here and clear this up, and I cat out etclogrotate.conf, here are the general log rotate configurations if nothing else is configured. These ones up here are the ones that kind of ride if you don't give a definition. But then let's say you're specifically doing something with like syslog. We're going to go to etclogrotate.d, and in here, if we syslog, these files here, varlog, cron, mail log, messages, secure, and spooler, they have this occur. This is as they're actually rotating. We kill syslog d and restart it. But you notice that we didn't do a rotate or a create or a compress or any of those things. We left that to the defaults. Does that kind of make sense? So this only overrides if you don't have something in the default, but this can override. So if I went to like one of these like fresh clam log may override any of these defaults if it wants to. Now, the reason I show you guys that is if I ls-l in my varlog messages, I expect 4 back versions of my, and then my current of each of these. So let's say, yeah, here's varlog secure, and I expect 4 versions back at approximately pretty close to every 7 days because it's rotating on the, and that seems to be what we see right there. So good. So log rotation, very important to make sure that you're not using up the storage on your local machines. And then also understanding that there is a certain usage that's like when we're talking about incident response, typically like you want logs within the last 3 days. If you're talking about problems and things that are systemic that have been occurring for a while, maybe 30 or 60 days worth of logs are more useful for that. And then after that, logs really start to cool down and not being super useful. So maybe you start to compress them down or remove things that you understand to just be information. Maybe you only keep warnings and crits after a certain time, right? There's all these things that you can do to further compress logs as you go. So that's not something we hit heavy in here, but it's an important kind of concept to know exists. All right. So let's talk about sending logs off the server. I said earlier that this is maybe the most important thing about the week. there's going to be 4 common architectures, and these are going to be all the things that we do in the lab. So there's rsyslog, which is forwarding and collection of the rsyslog. The rsyslog daemon is already running on most all modern Linux. So what you do is you just take one and you say, you're the catcher. And all the other ones can then be set to send to that catcher. You can use that over UDP. You can do that more secure with certificate signing and TCP. But as a general rule, those services were already there. You're just configuring them to send off. And this is a very common up to thousands of nodes type configuration. rsyslog forwarding and collection. There are some problems with it, and we'll get into that in this next part where we look at the right architecture. But rsyslog works really well. It is part of the STIG standard. So I've been working on government systems that have all kinds of modern stuff, and then they're like, well, for the standard, we have to turn on syslog. And I'm like, well, but we can do, and they're like, it's in the standard. And you go, and guys, like, I know this is going to sound silly, but sometimes that's what you have to do. If the customer calls for it, there's not really much you can do. You just got to do what the customer says. So rsyslog is a great way to get logs off of systems, but it doesn't have all the robustness of some of these other ones. It doesn't have redundancy built in. Very low on the budget side and the technical expertise side, but it's not necessarily as scalable for sure up into the tens of thousands of nodes. And it's also not going to be as... you can't put it behind the load balance. There's a whole bunch of things you're not going to be able to do with this that you can with some of these other ones natively. All right, so this is, again, some service on all your machines, and you just configure it. Log aggregation is the idea that agents, you put some agent on your machines, and it's going to send back to a centralized platform. The common ones for this are like ElkStack. A lot of you guys have probably heard of ElkStack. Splunk. Splunk is very common, very expensive. They're on the more expensive side of things, but they back it up. They're very good. Graylog is free. It's an open source tool, but you're not going to find a lot of people with a lot of expertise on that. I've never actually set that up myself. And then Loki. Loki is a very common one nowadays that works well with other tools like Grafana. It's actually part of the Grafana stack. And then we use like Promtail, or we can send stuff directly into Loki from our applications, right? So some agent of any type or even built into your application sends it to a centralized platform. That's what's going on here. So that's pretty good. Pretty robust, has some things. We'll talk about them in the next slide. And then there's message queues. Message queues are kind of the most modern way, and the way that I've watched emerge the most, especially in like the log formatting side of things. And the message queues, or sometimes called event buses, and you'll hear event-driven architectures. Event buses can just sit there as kind of like a subway through your whole system. Kafka's a big one. RabbitMQ, if you're up in the cloud, like Event Bridge on the AWS side of things. I don't know what they call it in the other ones, in the other platforms, but I know Kafka is up in all the different cloud. There's even an MSK, which is Managed Services for Kafka through AWS. But message queues are, you're sending logs in there, and you can replay the whole events of a day. And you can see later exactly all the transactions that occurred. This is used in a lot of banks. I'm going to show you guys when we get to the lab the funny thing that I found on this, but it's Apache, by the way. Put some respect on its name, Apache Kafka, and it's very well adopted. All right, I'll tell you guys, it's in 80% of the Fortune 100 companies. Is it Event Hub in Azure? Yeah, I don't know all of them for all the cloud, but so it's the same kind of thing. We've got a place where, guys, I just think of it like a little subway where you could just toss your messages on over here and they can go around and they can be pulled off somewhere else. And we call producers and consumers and then topics and then we have all kinds of stuff. Kafka is a very robust tool. As well as I know it for the logging side of things, I know that I don't know all these other things about it that are also super useful. And then there's the cloud native logging services, which are actually the ones that I was kind of mentioning earlier. Although EventBridge is cloud native, but when I say cloud native, I mean more of like the logging that's already coming off of systems and VPC flow logs with their 9 fields of did we allow or deny the traffic? That's awesome because even if it didn't come in, we still log it. Timestamps, formats, source port, destination port, all these things that we care about from a networking standpoint, we can capture. Now, we can capture all those things up here as well, but in a cloud-native system, it's already built in, so you might as well use it, right? That's kind of the thoughts behind it. But these are kind of the 4 big architectures. I'm not telling you there's not other architectures, and I'm not telling you that there's not sub-architectures to each of these types. I'm just saying that these are common architectures that we're going to examine in the labs here. In fact, in our discussions, I I always challenge you guys, go find other ones. Go find other ways that the industry is going. I can only talk to things that I've built and things that I've read about in the industry, but these are kind of the big ones that are out there. All right. So why would you decide one of them over the other? Well, maybe there's a scale. I said that that our syslog has some scaling issues. I've used our syslog up to probably about 2,000 nodes to one backend node, and that's cool. That works. That one node was chilling. It didn't have high CPU or RAM. There's a little bit of disk I/O, a little bit of network, not too bad. But one of the limitations of that, obviously, it can't scale too much higher than that. But there's also this right here, reliability. How critical is it? I don't have like a VIP, like a virtual IP, where there's a secondary R syslog sitting there, by default, let's say, that all the logs are always going somewhere. And you say, well, maybe that wouldn't be too hard to build. Yeah, sure. Maybe it wouldn't be too hard to build. But for just like a base R syslog system, scaling is always going to be a little bit of an issue. Real-time analysis data needs. R syslog is not designed to do anything but send logs. So there's no way to look at something in like a real-time alerting or dashboards. You'd have to build a secondary tool on top of it, a cron job or something watching those logs if you wanted to do that. And that's not really real-time. That's not processing things as they come in, right? You are going to get that on Splunk. You are going to get that on your other tools, right, that do that. You can do that with Kafka and those kind of things as well. Yeah, reliability. You get way more reliability with tools you pay for, like with Splunk. You get a lot more reliability where you have like a Loki API endpoint, and then you can have multiple API endpoints behind a virtual IP, which is just a reverse proxy or what we call a load balancer, right, at that point. The budget, right? Some things are free, right? Graylog free, Loki free, but, so that's cheap, but you pay an expertise typically. So like, whereas like Splunk is prohibitively expensive for a lot of smaller organizations. Splunk is very expensive, but you don't, but you also have a fair amount of people that know Splunk well, and it's a reasonable amount of expertise and costs to get people in for Splunk. Graylog, I don't know any like Linux admins that have Graylog on their resume. So you start using Graylog, you're going to have to trust that the people who set it up, and maybe, you're going to have to look for people, right? There's not a lot of expertise in that space. I'm not saying that there's not a lot of people using Graylog. There are. It's just you're not going to find that on anybody's resume. You're going to have to go looking for that. Compliance, right? Remember I mentioned earlier that our syslog is actually a STIG requirement. Well, when I do government systems, I have to STIG them to at least 90% of all compliant STIGs. Well, if I toss out our syslog for some reason, I lose probably like 5 or 6 of the STIGs that I could easily turn on by having it on. So sometimes you got a compliance requirement. And you might say, Scott, that's really stupid. You're telling me that I have to check a box just to check a box. Have you guys never done security? That's exactly what security is. In fact, there's jokes all over the internet about, well, we were doing all these things, but we didn't catch the person that came in. Well, we weren't looking for them. We were just doing security like mindless drones, right? And that's been a big part of this course. So I want to show you guys this, but I don't want you guys to just, check all the STIGs and then sit back and go, well, my system's secure, because that's not it, right? Anyways, compliance. Sometimes compliance is there. Sometimes you have to adhere to certain things. Maybe you have like a HIPAA requirement to use TLS, and you can't get TLS to work with our syslog. I mean, you should be able to get TLS to work with our syslog, but let's say you couldn't. There you go. And maybe it's what you inherited. So maybe as you build out more stuff, you find that it's easier to just continue on because there's no compelling reason to change to something else. But in one of our labs, we're actually going to have Loki up and running, and then we're going to plug Kafka into it. So we're actually going to slowly move to a different architecture as we do it in one of our labs. So we'll get to that here in a little bit. But these are the things to consider as we send logs off a server in relation to these 4 architectures that we're going to look at. All right. So then using the logs. But once I have the log, what do I do with it? And here's the thief. And he says, well, that's simple. You just join. All right, if you guys don't get that joke, you got to go watch Conan the Destroyer. And then he runs off scared because he's basically explaining to her what sex is, and he's very scared to talk to her about it. It's kind of funny. All right, so then what does parsing look like? There's 2 ways that we parse logs. We can do it directly on the machine, right? So understand the log format, go look at the logs a little bit, start simple and start to carve up the relevant lines, use regular expressions and find different patterns and that kind of stuff. Maybe iterate and refine, and then save off useful commands for later, right? So this is kind of a way, you might do something like this. I was showing this yesterday to the guys. We're here in my home lab, and maybe I grep. Let's just look at the log format first. So maybe I do like a tail dash 200 on, let's just say secure, right? So I look at everything in secure, and I go, okay, we're using, this is definitely the BSD style RFC format. We see the name of my server. We see the process ID of somebody trying to come in as some unknown user and then failing to come in, and here's the information about their user. So maybe I look at all that and I go, okay, well, I see something in the kind of my raw looking at this data that I want to know a little more about. So I say, okay, maybe I just grep rhost from all the logs. So secure everything. So all the secure, I want all those rhosts. I just want everybody that's ever tried to log into my system. And I go, okay, there we go. And then I say, okay, we want to then maybe get just that line, which is we want just that column. And this is a pretty long line. I could count out 1, 2, 3. I can count forward, or I can actually count backwards here. So I can say awk and give me, from awk, give me nf, I think it's $sign out here, nf -1, and let's see if that works. Oops. Oh, you got to close out the brackets. Can't be out of syntax. All right, that'll give me that, right? And so real quick, what did I do? Right? This is useful maybe if you don't parse logs a lot. With my grep, I knew that this was kind of what my lines were going to look like, right? And oh, actually, sorry, hold on. I have to grep. Where did I have it? I should have done this a little smarter here. Hold on. Let's go to the one that I ran. I should have done grep. Oh, we already did the rhost. Yeah. All right. So let's go look at that real quick, and then let's look at it without the awk on there. And what we see is in any of these systems, we looked for one line back from, or one column back from the end. So on some of them, rhost is the last one. And here's the thing. Some of them it's not. All right, so now we've got a problem. Let's get rid of, let's deconflict something here. Let's say all the ones with root. We'll grab all the ones with root. They all have it correctly. But all the ones without root, so we grep-v root, all of those are just nf, right? And then it would be user is whatever, or rhost would be whatever. And then that's like a much better kind of format, cleaning that up as far as that goes. Now, I could maybe take this and then I could do, there's all kinds of fun things we could do with this, but one of the fun things we could do here is once I have all these, I can say, all right, let's real quick, we'll go ahead and sort these all. So we'll sort, and then we'll do a unique -c, and we will see how many of these were logged into or attempted to log into by each of these. So I can come up here and I can go, okay, some IP address came in a whole bunch. Now, a bunch of people use the home lab here, so there are legitimate reasons for external IPs to hit my home box. There's a whole bunch of reasons. But I can parse these down and find, oh, look, here's somebody from here. Here's all the times users came in as MC Hammer. Here's all the times somebody tried to come in as MySQL, or any of these other users were doing something in my different systems. Here's Streamer 1. Streamer 1 is how you guys connect when you're coming in as the Linux sysadmin course. MC Hammer is how you guys come in when you're doing the security engineering course, right? This is through the Bastion, and you get jailed as the different users, right? But I can parse this stuff out. And for general log stuff, let's look at something else real quick here. Let's just let's just tail like -20 messages. And we go look at messages real quick. And I say, you know what? I kind of want to look over the aggregate of all the time that I have for how many logs we had each day. Maybe I'm looking for events based on log density, right? And I might do something like this. I might grep. Let's cat messages, but all messages, right? Get all of them. And then maybe we just say print out the first two columns. So that's $1 and $2, right? So we get those, boom. But I want to aggregate those up, right? I told you guys earlier that we want to aggregate those. So then I do a unique, sort, and then unique dash C, and I can just count all those up here while I'm drinking my. So if I go looking through messages, I see about 21,000 messages a day. This is actually interesting because when I did this yesterday with the guys, I did it with Secure, and there was a clear far outlier and something that we could go dig on from like a security standpoint. Here, all my systems, logging for messages looks pretty much the same. Let's go look at that same thing with Secure. We'll see a clear outlier where something was happening in my environment. Look at these. Oh, maybe I was looking for like I think I grep failed. Cat secure. Grep-I failed, right? And then we had here was this one clear outlier of there were so many more failed attempts on April 19th, and I probably want to go dig in and see if something was happening on April 19th because that's a weird outlier against maybe about 350 a day average. It's kind of a high outlier right there, right? So maybe I want to go look at what was happening. Was there a concentrated attack from multiple IPs? Do I need to go dig in? But to show you all that and to say that I've been doing log parsing for a while and I'm okay at like looking at stuff and kind of correlating stuff. Even then, I want to show you guys something. I was still using systems because don't you guys agree that if I had opened those in like VI or more and started just looking through them, you'd have been like, all right, I'm leaving. I don't want to watch this anymore. This dude's nuts. So just real quick to say, the system is way better at it than me, even when we're manually parsing logs. You're never manually parsing logs by reading them. You're always using the tools that kind of exist. I hope you guys know that, because then when we talk about this, when I admit that the system's already better than me at this, then I know that I should be using the special tools. If I'm getting the logs off in real time, there are all kinds of tools that are out there designed to do this for me. Splunk builds profiles. LogQL will allow us to query things in the system and pull information out of a bunch of different systems, but Loki is one of them as well. So this is in the lab, so you guys will get that when we get to the lab part. And then, by the way, if anybody's looking at this and going like, hey, I'd like to follow along, I have all the labs down in the Discord. So this stuff's all available for you guys if you want to do it. This is a free course. I'm just recording the free course right now. Elasticsearch, Logstash, Kibana is the Elk stack, and then Graylog. And then there's libraries. We can go actually just talk directly to some of these tools, right? So there's all that kind of stuff where we can pull information out and make sure that things are talking the way that they should and that kind of stuff. All right. So when to use the special tools? When there's large log volumes, there's complex log formats, and maybe the date and timestamps aren't great. You need real-time analysis. Like, I'll go find an error eventually if you ask me to, but I'm not going to do that as well real-time as some of these tools that are designed to do it, right? Even if I have 20-something years of doing this, it's not going to be as fast as these tools. It's just not. And then requirement for visualization, we can visualize and put these up on the dashboard and have people monitoring for real-time errors. We could do security analysis and look for patterns and things that, anytime we're talking security, and especially security events and security incidents, they're anything that affect a system from the confidentiality, integrity, or availability of the system. You guys hear that CIA triad all the time. Well, that's how we do security incident categorization, is did it try to go against one of those three? By the way, almost all attacks affect availability. So almost all attacks, almost all incidents, even like just somebody tripping over a power cable, is still a security incident because it still affected availability of a system. So it's almost like no matter what you do, you're making a security incident. But anyways, and then sometimes for compliance requirements, you have long-term retention and auditing from government or industry-specific compliance standards. I tell you guys sometimes there's a compliance standard out there that most of you have probably heard of. It's PCI DSS. It's the payment card industry. And the payment card industry, there's no law that says you have to follow that at all. Like, if I want to start taking credit cards on my phone, if I want to start taking information, as any company and trying to store it and processing it locally, The problem is if I don't follow that PCI compliance, I can't connect into any systems that are also PCI compliant. So now I can't actually do any processing. So it's one of these things where there's nothing forcing you to do PCI-DSS compliance except the fact that you want to do business with credit cards, right? If you want to do business in all cash, there's nobody making you do that. So anyways, compliance requirements, some are, regulations from the government, some are industry specific, some are just kind of the de facto standard. And all of these have logging requirements as well. So let's review a little bit. What is a log? All of these things that we talked about, all of these things right here are going to make more sense, I think, for a lot of people as we get into the labs. So let's pull that up. I'm going to pull, so again, review. We talked about what a log is. It's an immutable record. How do we use logs? We use them for security incidents, regular incidents, any type of pattern identification and correlation of things between systems that are occurring. What are the common log elements? Well, they're defined as these RFC standards, typically a timestamp, typically the host name of the system that it's going on, and then like the name of the process and the process ID, and then some short message. That's the general things. Where do we store them? Well, we have some local stuff, and we try to rotate it so we don't use up all the space, and then we get off the servers in real time through one of the 4 architectures that I talked about. Again, there could be other architectures out there, but the ones that I'm kind of showing are probably, well, they're 100% of the ones I've run into, but they're probably like 95% of the ones in the industry, right? And then how do we parse and look at specific information? Well, we do it at the command line, but we're using tools still. And then there's also tools that are specific to this that will help us to visualize it and show it to a larger audience than just, I tell you guys all the time, you're not going to get a lot of your people in your company doing all command line all day. So you've got to have tools to show the other people kind of what's going on. All right, so we're going to go hop over here to our lab server, and we're going to jump into Hammer 25. Actually, you know what? I might not even do too much with the Hammer servers, I think, in these labs, but let's go look at what we're doing for the course here. And we'll start with the worksheet. If you're doing the labs with, or if you're doing the course with us and actually following through the course, you have to do 2 discussions a week per topic. So you got to come in and you got to do discussion post 1 right here, and then answer it and give somebody else a response. And then you also have to do discussion post 2. If you're following along with the course and you want the little certificate at the end that we give, which very few people have that certificate because very few people do all the work, but it's there. And discussion post 1 is read chapter 15 of the SRE book, which is out on Google. And then there are 14 references at the end of the chapter that I think are valuable. And once you've kind of read through and skimmed that, I say, what are some concepts that are new to you? What didn't you know before about securing and reliable systems, specifically around collecting appropriate and useful logs? Because obviously we could just collect everything, but we want to collect useful things. What are the useful things? And I said there are 5 conclusions drawn at the end of this book. When you get to the end of this, there's 5 conclusions drawn. Do you agree with them? Do you like them? And then one of the 14 references is this one. I actually really like this. Let's pull this up real quick here. And this is a debugging. We're always talking about troubleshooting through all these different courses we run. We talk about troubleshooting. And this is a nice little blog that's linked out at the end of it that talks about troubleshooting using logs and how you troubleshoot. But it's called debugging, but it's still troubleshooting, right? And what I ask is, what are some useful things that you learn, and how does this help you to understand kind of what you already know about logs? Like, logs should be useful, and they should be timely, and they should be all these things, but how does that kind of help you in relation to this? So I have you look at that, right? And then the second question talks about monitoring distributed systems. And I mentioned earlier that I would tell you guys these 4 golden signals. So you're reading all this and you're thinking about what's new, and you get down to the 4 golden signals: latency, traffic, errors, and saturation. Now, from a system standpoint, you guys have heard me, if you've been around, I always talk about the utilization, saturation, and errors, the use methodology of systems administration. And the use methodology is look at how used it is, look at how saturated it is, I mean, how much of a line and a wait there is, and then look at the errors coming off of it after wait times are exceeded and those kind of things. They're talking a very similar vein, but more on the application side, right? So anyway, so you read through this a little bit and you answer these questions. And I said, after reading these, why is immutability so important to logging? Because you're going to find that there's a decision a lot of the times to like, well, we should change this or we should put this little note on this. Yeah, you can put the little note and it can be off to the side, but the log itself might as well be chiseled in granite. You are not changing that with your little markers and stuff. You can add and you can append and you can put all these other things around it to inform what was going on, but you don't change the immutable log itself. That line is like, I almost want to call it like sacred to us, as far as like I can replay things and I can look at things, but I don't change those logs. All right. And it should, and you might say that sounds fanatical. You should be fanatical about it if you want to keep control of your systems, right? All right. So then I have a bunch of definitions and terminology. This is your worksheet for yourself to go and find these things. Here's the Loki data analyzer that I told you I'd show you guys later. And you can go in there and you can practice log QL. And you can look at how the queries affect the logs. And you can even put your own logs in there. But I highly advise do not ever drop your company logs in there. Don't drop live production logs in here. Drop stuff out of your home lab in there. Drop stuff out of servers you don't care about in there and learn how to parse. Sure. Do not drop corporate stuff with real events in there. Because, look, you might say, yeah, well, I don't think Grafana wants my stuff. Maybe they don't. They probably don't. In fact, I bet you this back end, this is just a text box, right? I bet the back end of this is a large input box is probably going nowhere. But the security guy in us can't let that happen, right? You guys remember those old mini wheat commercials, and it was like the child in me likes this, but the adult in me, well, the child in me thinks this is awesome to go run queries against, but the adult in me is like, oh hell no, I'm not putting my stuff in a box that when I hit run query, I don't know where it's going. Why would just don't do it? Okay, don't, especially if you're working in government systems, man. Now you're starting to talk about going to prison, right? That's stuff not to mess around with. But I'm just gonna tell you, it may never come back and it may never bite you. But why risk it? Like, why mess around with that? We're security focused in this course, so we're thinking about it like that. All right. Anyway, so then we talk about useful tools, and the lab assignment is the logs and parsing lab, so we're going to get into that here shortly. And then digging deeper and reflection questions are always for you guys. They are not required as part of the course. But digging deeper is go find a cloud service and go look at their logging best practices. What does Amazon tell you to do? What is Azure and GCP? I know the most about Amazon of any of them because that's the one I got a bunch of certs in. But I've never really used GCP, or I've used Azure a little bit for the college. But what are high-level concepts? And by the way, if you were to go compare the high-level concepts of one cloud to another, you'd find it almost looks like, you guys ever seen that Mr. Bean skit where he's like looking over the other guy's paper and like taking his answers? It's like that. It's very much that the concepts are the same across the board. Not that anybody's cheating off each other. It's just they're the right concepts, right? And then I say open up the Stig viewer. We've been doing that Stig viewer this whole course. And I say go start looking at all the logging stuff that we kind of glazed over before, but now we're in logs. And look at what they think you should do with logs and where logs should be going. And you're going to find all the same type of things that we're talking about here. And then I ask you some questions, and then there's some research. I always ask these two questions. What questions do you still have about the week? We have a section in the Discord for you to ask questions. And then how are you going to use what you've learned in your current role? We have those, you can answer those. And then I just have some architectures. Have you used any architectures in your career? Have you seen any of this stuff? And if you haven't, what about the stuff that we work on here in the lab would you apply to like the ProLUG lab? And this is actually about how much stuff we have in the Professional Linux Users Group lab here. Got about 60 virtual machines, 4 physical machines, 1 NFS share, and we have some other stuff going on, and then 2 Windows laptops just in the house here. I didn't include all the tablets or anything like that, but what might you do with that? How would you maybe log that if you were doing that for a company? Because that's maybe what a small office or even a medium-sized office might look like. So now you're starting to do like real architecture stuff. All right. Let's get into the lab. If you want to do the labs with me, you can. They're going to be up on Killer Coda, and that's a completely free site, so I'll be linking that to you guys as we go. But also, we have a book for the course, and you can go find that in the Discord as well. That's completely free. It's a web book. The guys have been putting it together. It's really good. So I come down here and I say, in keeping with the lab for this week, there are 4 major architectures for collecting and storing logs off of a system, right? Within each of these architectures exist many mutations, but the archetype that solve different problems addressed within scale, reliability, real-time analysis, budget, expertise, compliance, existing infrastructure of the systems being logged. So there's all these things to consider. I'm going to show you setting some of the stuff up. So we come down here, and the fourth type, the cloud type, I'll just show you where you can go do the logs. We're not going to actually do those logs, the labs for the logs there. All right. So our syslog looks kind of like this in our environment. This is kind of what our little lab looks like. By the way, this is up in the Discord, and it's on the book, so if you need it. And the first lab that we're going to do is this basic little killer coda lab. Some of you have maybe even done this lab with me before. But I'm going to link it for you guys here in case any of you want to do it. So drop in there. Killer coda is completely free. You just have to log in with an email. They don't even bug you on email. Like, I've never been bugged by them to like buy anything or gotten any weird stuff. And then as we do this, as we follow that architecture, here's the questions I want you to ask. How do we split out the lab? Why did we split out? And why don't we just aggregate them to one place? How does the template configuration work? And then are we securing the communication in any way, or do we need to do that still? And then I say we'll revisit this in Unit 10. We're going to do the same lab, but with TLS applied. So we will secure it via certificates. One device talks to one other device, right? So make that a little bigger so you guys can read it. Your team's determined that they need to centralize logging in the environment. Cool. All right. There's some other stuff from management. We're not going to worry about that. Let's just make sure that, like I said earlier, modern Linux systems have our syslog running. So our syslog, boom, boom. By the way, hey, Colchis, I see you there. We're going to make sure that it's running. You might have to hit Q on your system and then make sure it's running on the far node. So, okay, we got the package on both machines. We knew it. It's modern Linux. It's going to, and then we make sure that it's on. Cool. So like I said, one agent is going to become the server, and then the other agents can all throw to it. So let's go on our system here. We're going to VI our etc our syslog, and we're going to come down to these two lines right here. Provides UDP syslog reception. Again, catching. We're going to come down here, and we're going to allow module IMUDP and IMUDP on the default port of 514. Escape :WQ. And real quick, just for fun, we're going to check, is 514 open on our system? No. Then we're going to restart the syslog. And is it now being listened to? Yes. Now, there's a question I always ask for like the more junior members, but if you're following along with security engineering, you're not, I wouldn't consider most people doing this to be junior, especially if you're following along. The reason that when we changed that, it automatically didn't turn on is because none of your system D processes go and read the config file in any type of real time. They only do it on restart. And there's a security function there. There's also a stability function there too. Because what if I was editing that file and just saving it as I went? Like I just do a :W every few minutes, and I have this busted ass version of the config, and that system is coming back and reading it in real time. That's terrible. That would break our syslog, and maybe that's a critical service on my system, and now I've lost thousands of logs, and that would be dumb. So we don't see, or we don't read in real time. So that's why we didn't see it at first, and then when we restarted it, we did see it. All right, cool. Now we're going to go to node 01, and we're going to set node 01's our syslog. I'm going to hit Shift G in here, Shift G and O, and then I'm going to copy this line, and all this line says is we're going to send everything to control plane. That's all we're going to do. We're just going to send everything over to control plane. Escape :WQ, restart syslog over there, exit to go back to control plane, and now I'm just going to sit here while we talk. And we're just going to watch tail-f varlog secure, where that is sending everything to. And we see right now control plane, because remember we saw, oh, by the way, isn't this that newer? This is that IETF standard, not the old Berkeley one, because look, we've got a TZ here. This is a what we call an ISO 8601 timestamp format. So that's interesting now. We know that. Red Hat systems are still using the BSD, and these Ubuntu ones are using this other one. I didn't notice that when I was setting this up. Control plane, we're still only seeing, oh, there's node 01. So we are seeing things coming over from that other system. So node 01. All right, we could watch that all day, but we're going to hit Control C, and we're going to go to the next part. And now we're going to split those logs out for, I don't know, simplicity's sake, maybe easier parsing later. And we're going to go on this local machine here, and we're going to drop into etc rsyslog.d. If you know anything about the .d directories, guys, what they are is they are appended to the end of your original conf. So etc rsyslog.conf gets read, and then the .d directories get read in order, or the .conf files in the .d directory get read in alphabetical order, but they're numeric, so it's typically numerical order, 00 through 99. And we just made this one, and we're going to add these lines to it as a template. And this is one of the questions over there now. How does the template work? Well, the template right here says it's named remote logs, and it's going to say var log, and then it's got this special variable that our syslog uses. There's a whole bunch of special variables. You can go read about them in man r syslog. And it's var log hostname messages.log. And the condition for it to occur are if this other variable from host IP, that's another variable that's special to it, is not equal to this machine, then use remote logs. This is their syntax. It's confusing to me as well because I also don't write in this often. This is the one thing I actually know how to do in our syslog format, by the way. And then when we're done, we'll stop using that format. So every time a log comes in, it's going to get applied to this. If you're not from this local host, 192.168, 127.0.0.1, then you get applied to remote logs, and now we would expect var log node 01 messages.log to catch all the rsyslog messages that come in from that one. Well, we'll expect that once we do our restart. So we'll do our restart of syslog, and actually if we go look, there's no file yet. Nothing has come in yet to generate that file and make that file exist, that whole path. But now, still not there. No pathing yet. We could make one. We could just SSH over real quick and it would catch it, but still nothing. I'll give it a second. By the way, we can go down here and see only control plane now. But then after that's done, we'll go back to our original one, and still nothing. Taking its time. Give it a second. You're embarrassing me in front of my friends. No, I'm just kidding. All right, there's the first one. Now, we could sit here and watch, and only node 01 will ever show up in there, right? All right, so that is taking our syslog, which is an agent already running. It's part of your Linux system. It's a service running on it. Turning one of them into a catcher, or however you want to think of it, and it catches the logs from any number of other nodes. This is node 01, but it could be through as many different nodes as we wanted to go over there, and then we could start to look at performance and how much it's catching and all that kind of stuff. All right, that's the first lab. First lab's done. Boom. The next lab is going to use agents to forward to a centralized platform, and we're going to use Loki because that's one that I know better than others, and it's also a lab that we already have set up. So we're going to go here. I'm going to link this lab for anybody that wants to do it with me. We were talking about this yesterday. Some of you guys have done this lab more than 10 times. You guys have probably seen me do this lab a lot. But now we're going to go in and we're going to do the lab, and then we're going to add some to it. So the lab looks like this. We build out Grafana first, and Grafana has a doc. You can go read about it. So we'll put in some dependencies here real quick. We'll get Grafana here. Give it a second. Yep. We will make sure that we have the keys signed, and then we're going to install Grafana Enterprise. It takes a few seconds. Once we install it, we're going to do a daemon reload. We're going to start the service. Service takes 10 seconds or so to come up, and then we'll go from there. So let's let this go. All right, daemon reload, start it, check on it, good. And then we're going to run this to see it's not listening yet. It's not listening yet. It's going to take a few seconds. While we're doing that, there's some stuff you can review over here. I'm a big fan of reviewing labs before you get into them, because if you just barrel through head first into a lab, sometimes people get stuck and then they never pick their head up and saw that like the next step might have helped them. So I'm a big fan of kind of reviewing a lab first before you jump into it. Let's go look again. Now we're listening. We should be able to click on this link, which will be unique in your lab. And now you've got Grafana. So admin. We're going to ignore all this stuff out of here. And we're going to put a new password. Get a new password up. Don't save it. We've got Grafana running. All right. Now we're going to do two other components of this, which are to turn on a tool called Loki. Loki is going to be an API endpoint for us to both push and pull logs from. So make dir cd in there. We're going to pull it down and unpackage it. We're kind of going fast through this part because the setup of this is something for you guys to do on your own if you want to spend more time with it. We're going to copy in a local config, and then we'll look at that local config. And yeah, all the things that we expect are there. It's going to run on port 3100, and it's all the kind of stuff we need. Okay. We're going to look at the Loki service, and the Loki service. Oh, I didn't copy that in yet. Copy in the Loki service, and then you go look at the Loki service, and it's a basic little systemd service that just starts this tool and calls that config file. That's all it is. All right, start it, look at it, it's listening, cool, we can move on to the next part of the lab. So now we got Grafana as a visualization, we got Loki to catch, we're gonna use Promtail to send, as an agent, to send logs up into the system. So make Promtail, cd in there, download it and extract it, copy in the files that we need, check out the service, cool. And real quick, I want to show you guys, here's the config, and here's the two scrape configs, which are going to say varlog syslog and varlog authlog are going to be the job syslog and the job auth. So remember that job syslog and job auth, because in Grafana, we map that to a thing called app. But those two values are going to be important here in a second. Job syslog or app syslog and app auth, okay? They're going to get varlog auth and varlog syslog. So restart the start the daemon and then go check it. It's running, good. Now we get to the end and we're going to set up this dashboard. All the things I'm about to do are explained right here, but we're going to go over here. We're going to go to a connection and install or configure Loki, right? Boom, Loki. Add a data source, 127.0.0.1.3100, and we're going to hit save and test. That, by the way, is all right here. Create the data source Loki in the data source page, URL right there. Now, we're going to import a dashboard, so we've saved that. We're going to import a dashboard here. We're not going to make a new one. We're going to import it. And we're going to pick 13639. 13639 is right there. Import the dashboard. Boom. Load. And then we need to pick the data source, which happens to be that data source we just made. And now we've got auth and syslog right here where I can see all of those logs being sent in from the Promtail user. Well, that's cool. That's a good start. We're getting a lot of syslogs and auth logs in here. But over here I say, while we're still in the lab, let's make our own little app. Let's make our own little send some stuff over app. So we're going to cd to answers. I'm going to move this over because I don't need all this and I want the real estate back. And clear the screen up. And it says to look at Loki write.py. Man, I wish I could type. And here's what's in Loki write.py. There's an import request, import JSON, import datetime, and import pi time zone. And then I'm using the host control plane. And then I'm pushing over down here a requests. Request is just a library in Python. And I'm doing a post of the URL, which is defined here, the data payload, which is defined here in JSON, and then the headers information, which is right here, right? And the payload is being pushed in up to that Loki endpoint. That's literally all that's happening here. You can play with it a little bit and whatever if you want. But I'm going to go ahead and just say Python 3, and I'm going to do Loki write. But hold on, before I do that, I want you guys to see something here. Let's refresh this page. There's only auth and syslog right here. They're the things that are being scraped outside of the Promtail. They're the only things that have been sent to this Loki endpoint. I want to come down here and I'm going to write this. And when I write it, I get a couple of good responses, so 204s. I have it print out twice because for dumb reasons, but now I come over here and I'm going to refresh this page. And now I should see lab logging. And you're going to say, where did that come from? And here's our 3 things that we just put in. There's an error that's been detected. Scott is too awesome. Whoever that Scott guy is, he's way too awesome. So over here, we come over here and we go back and we look. We say, wait a minute, can we see that in there? And here's our message that we were generating. And there is the label that we were setting, which the job, which is again mapped over to app, is lab logging. Well, that's what we saw right here. Lab logging. That popped up, right? We could keep modifying this. We could mess around and be stupid, right? What the hell is that called? Loki, right? We could modify this to not lab logging if we want, right? And just for fun, write a few more of those. Come back over here. You do have to refresh the page for this typically because it's not going to just pick that up. It's got to repopulate the app. But there's not lab logging, which says the same thing, which is also accurate as well because it still says Scott's too awesome. So there we go. Boom. We did that lab. We come over here. We answer some questions and we say, hey, can we read out of that? Can we read against the lab logging for the last 10 minutes? And the answer is yes. However, when you paste this in, you might get a little bit of a weird, I think there's a weird right here. You get added a line. So yeah, if you ran that, you'll go and you'll hit that query and you'll get a good JSON back. And then there you go. Yeah, guys, we should be in lab. This is unit 6. Yep. If anybody's trying to follow along. So now let's go do, we're going to do essentially the same thing again. Where we're going to build out the Loki part. And then we're going to say, but now for some dev reason, some development type reason, we have to add Kafka to it. So this is going to be our last lab here. I'm going to get out of here real quick. And we'll go ahead and get out of there. That lab's done. And let me show you guys my funny thing from earlier. I think this is hilarious. When you go look at the Apache Kafka page, they say that they are extremely popular. They're found in 80% of all Fortune 100 companies. Now, does anybody want to try to tell me what that probably is? How many systems, how many companies they're in? If you're in 80% of all Fortune 100 companies, anybody remember like 4th grade math, maybe 3rd grade math, right? All right, anyways, you can read more of the use cases here. There's some good ones. Here's our diagram. We're going to spackle Kafka onto the side of that. All right. So here's our lab. I'm going to link the lab to you guys that want to do it with me. Again, the lab is up on Killer Coda. It is free. I wrote this lab yesterday so that you guys would have something to do. And here we go. Linux developer, you're going to make me pull out my dad joke with that. You're going to make me pull out my dad joke with that. All right. So anyways, so here is our thing. It says our team has determined they need to offload monitor logs. We're going to blow through the first part of this because we literally just did it, guys. So we're going to blow through and we're going to install Grafana, Loki, and Promtail and get that going on our system. So Loki, we'll do Grafana first. Get all of this installed in this new system. And then I said, did you get it all to work? And does the flow make sense of what's happening? So we're going to get that. We're going to get that. We're going to install Grafana. That's going to take a little while. We're going to do a daemon reload. And then we're going to go and we're going to configure it again. All right. So let that go. Let this configure here. If anybody's wondering, yeah, if you came in late, we are doing the Unit 6 recording for the Professional Linux Users Group Security Engineering course. So that's where we're at right now. We're going to do systemctl daemon reload as soon as that comes up. Then we're going to do a start on Grafana. And we're going to check it. It's running. And we're going to give it about 10 seconds or so. Takes somewhere in there. And we'll verify that it's listening right here. There it is. It's listening. All right. We're going to pull this up. And we're going to log into the system. Admin. Boom. I change that over. New password. Make sure it's super secure. Boom. Got a password. We're in the system. I'm going to come down here. We'll go over to the next part. And we'll go install Loki. Again, I'm blowing through it because we literally just did it. And also not necessarily the point of this. To have, this is your existing infrastructure, let's say, in your company right now. I do advise going through this and understanding all these components because you will get some value out of understanding what these things are in the system. All right, it's running 3100, that's Loki. And now we're going to take Promtail and feed logs into Loki. So Promtail, make it, download and extract it, copy the things in that you need, and then run the service. So status, it's running. Cool. All right. Got all that stuff running. Now we're going to set up this Kafka portion of it. The Kafka portion is a little newer to some of you, but it's from a different lab that I put together. I kind of squished two labs together and then just made them work together. But we set up all the pieces. Oh, let's do the Grafana part. We got to set up the Grafana piece real quick. So let's make sure all the data are flowing. Same type of connection as before. Connection, Loki. Add new data source, and then we'll 127.0.0.1 and we should be able to save and test. Cool, it's all working. We'll go and we'll import the new dashboard. Import and 13.639. Use that as a data source. All the same things that we just did a few minutes ago, right? So now we have auth and syslog coming in because those are the two defined data sources here. Right there. So those are the two scrapes that are happening, job syslog and job auth, that map over here to auth and syslog. And if you say, Scott, how do you know? Well, because you can come here, you can make this editable. Like this is just, again, a little bit more of this. You can go in and edit. And here's the mapping right here. Sum count over time job is equal to app. So we're getting app in. And job is the search, right? Job is the value over here. But we're giving it app from our side up here. So Grafana has a separate mapping, if you will, to that. And you could configure those mappings any ways you want. If anybody's ever looking to do that or work on Grafana, let me know. It's I think it's pretty valuable to know how to do that stuff. So, okay. So we got our Grafana up. Loki, so our whole pathing is syslog events are happening in a system. Promtail is grabbing them, sending them up to Loki. Grafana is validating and showing it to us. Cool. Now we're going to do a completely different thing. We're going to set up Zookeeper and Kafka. Kafka needs Zookeeper or Raft on the back end. Raft is the newer way, Zookeeper is the older way, so I'm kind of showing you guys the older way. But that's not really, that's orthogonal to the point that we're making here in the lab. So let's go create a namespace for Kafka because you are on a Kubernetes cluster. We'll go and get everything in it. Well, it's empty. It makes sense. We just made the namespace, so it should be empty. And we're going to make this Zookeeper file. If you want to know how that works, I've got a different lab that shows you that. That's not really part of this conversation. But now when we go look, here's all the things we created. And it's not ready just yet, so we're going to give it another second. And see, there's no endpoint defined yet, so we give it another second. And now it's all up, and we're ready to move forward because 2181... 2181 is the Zookeeper port, so the Zookeeper service is going to front end that, send it back to the pod, Zookeeper's up. Now we're going to go down here and we'll create the Kafka portion of it, which again we review in a different lab, so I'm not going to do now. And now we go look and we see that it's not ready yet. It's going to take 10 seconds or so. It's pulling down the pod. It's configuring it according to, if you really needed to see it, here's the... There it is. Here's the environment container configuration that I give it. I tell it the Zookeeper service is here, and that's how you're going to connect, and that's how you're going to talk and work. So we're doing all these things, and when I'm done, I should see that they're both up and running and good, and then we're ready to move on. We're going to set up a tool called Kafka Cat. So from the bash command line here, we can send messages up into our working Kafka. So that's what we're going to do here. Pretty straightforward to set that up. We're going to set port forwarding so that our system is going to forward 9092 into 9092 on the system. We just have to do that, so that works. And now I can send a few Kafka Cat messages, which, by the way, they changed down to KCat instead of just Kafka Cat. And then now I should be able to read that out of Kafka. So a few messages went in. I pulled all three of them out. Cool. We got that part working. That's all set up. Now our team's going to set up, we've set up Apache Kafka, and we're going to test this and send it over. We're going to use Promtail to read those messages out from the system logs topic and send them over to Loki. So that's what we're doing next. Now in this first window, I'm just going to say every 3 seconds, send a message. This is my message. It's going to generate a random number between 1 and 10, and then it's just going to loop. So this is going to loop forever. We're going to leave that tab open, and we're going to make a new tab. So right here, I just made a new tab. Now back there, it's still making Kafka connections every 3 seconds with random numbers. Now over here, random messages, if you will. Over here, we're going to go modify our Promtail, and we're going to add at the bottom a new scrape config. So right here, we've got 2 scrape configs already, but they're reading from files. and we're going to go say scrape Kafka. Go ahead and scrape Kafka from node 01 port 31000. The topic will be system logs, just like that. And the label we're going to add is job Kafka. So we would expect that to be in our Grafana under app Kafka, right? Escape :WQ or shift ZZ, I don't care how you do it. Restart PromTail, so now that's reading. And if I come back over here and refresh this page, I shouldn't just have syslog and auth anymore. Now I should have this Kafka as well. And I should be able to sit right here and set the refresh to 10 seconds. And right here, I should watch this. Look, I'm gonna move my hands up here so you guys see I'm not touching the screen in any way. I'm not touching the keyboard, nothing up my sleeves. That's going to keep refreshing and showing me every 3 seconds that new message being popped into that system. So if that were an application that we're writing out into Kafka, it would be writing to the topic system logs. System, whatever we called it. That was the topic. And then PromQL is now scraping it and pushing it over into our Loki configuration. So it's another way. Maybe you put like a brand new, maybe you put OpenShift in, and your architecture team decides we're going to use Kafka to do all of the monitoring, all the stuff. And you go, well, that's cool, but like enterprise monitoring over here is already done with Loki. Well, now you can have a tool like PromTail sitting there, pulling messages out of Kafka from the topics that are interesting, sending them over to enterprise monitoring. It's a way to, we're both exploring the new way of doing it, which is this what we call message queues or event bus, but also integrating it back with like your existing company infrastructure. So we're doing, again, I tell you guys, when we do this stuff, I'm not just trying to make you guys like drones that like blindly say you must do it this way, you must do it that way. I want you guys to understand the different architectures, because you're going to run into all of these at different times in your career and do different things. And this is us adding Kafka maybe into an environment for testing, but we still need to get it up into the enterprise system that's already there. Or maybe you're building this out for the first time and Grafana just happened to be the best tool to show dashboards. It's a pretty good tool for dashboards, right? Like you guys just saw me grab this dashboard off the internet, right? This dashboard's free. It's great. Change all kinds of stuff in here. Maybe I don't even want the last hour. I just want the last 5 minutes. How are our logs doing? What's going on here? You know, what are we seeing? So, all right. So we back out of here. And then the last part of the lab is very optional. It's cloud native logging services. And I say set up a VPC flow logs in your AWS environment. And here's a what we call part of the well-architected framework that shows you how to do it. And I said optional, even if you're not completing these labs, go read about it a little bit. I'm a big fan of just like at least skimming over stuff and understanding. Here's how flow logs work. Remember we were looking earlier at like the specific format? Well, here's their specific format right here. Tells us exactly what's happening right here. What's happening? There was no data on this one. But generally, you have all this information. This should be, I believe it's the type. This is the timestamp. This is the interface that it was flowing. You've got the source and the destination. And then somewhere in here, you're going to have the port numbers and if it was accepted or rejected, right? Accept or reject and then okay. And they have right here, they should have all the format. They're just giving you examples here. I thought they had a format guide somewhere here. I don't see it. Maybe flow log records are right here. And it shows the data format. So version, right? What version is it? 2, 3, R4. Yeah, here you go. Count ID. All right, so there's your AWS information. Interface ID. Oh, so that wasn't even the timestamp. The timestamp was somewhere else for that account ID. Interface ID, source address, destination, source port, destination port, protocol, TCP, UDP, sometimes real-time transfer protocol, RTP or RSTP. Packets, bytes, start, end, and then the action if it was accepted or rejected. And this is very important to understand if you're going to be doing networking inside of AWS. Security as well. Log status, was it logged? Was there no data, or did we skip some data because of definitions that you gave? Then more information. Look at this. I don't even remember seeing any of this before. Must be all optional data. Anyway, so there's that. Digging deeper, again, these are always not required for finishing the lab, but for Architecture 3, you can go look at how InfluxDB was used with, this is at a company called Wayfair, And the reason I give you guys this one, the reason I really like this one is this is my first intro when I did InfluxDB with Telegraph. But if you look right here, they've got a really good architecture drawing that I think, this is like one of the best drawings I've seen that shows like, hey, we were using all these apps and then we were sending information into Telegraph. And then over here, we were pulling information out, or we were sending information in. And then here, we're pulling it out of Kafka. But Kafka's just a bus. It's just spinning like this through the system. It's like a bus line up and down on 59th Avenue in Glendale here. Just a bus line. And you can hop on the bus wherever you want. But this is where you get pulled off the bus to go into the InfluxDB. And then this right here, if we were drawing this up from what we just did, this goes off to enterprise reporting and enterprise visualization and stuff. This is their architecture of all their apps. Any app they had sending information into Telegraph, but what they found, and if you read this blog, that's why I think this is so good, they show that there was unreliability here when they were just sending Telegraph. So then they put Kafka in between, and Kafka became this, again, it's like a system bus. It's like an actual literal bus line just running through the city that's always on time. It's always there. Kafka's always ready to write, right? So anyways, there's that. Review some anti-patterns. I'm a big fan, guys. I talk about anti-patterns. You don't hear me say this much, but this is a big engineering thing. When you talk about an anti-pattern should always be something that is against the norm. And it should work not just in like the first architecture we looked at, but all architectures. If I say something's an anti-pattern, like look at this. Logs are stored in perpetuity. That's a problem. Why would I want to know like the system boot up time of a server from 10 years ago? I don't give a shit about that. I care about like the modern one that's been replaced 3 times since then. But logs stored in perpetuity, that's a problem. Or deleted too soon, that's a problem. Both of those have their own problems. Remember I was talking about like incidents are typically only like maybe 3 days. Problem resolution is maybe 30 days to 60 days. But why would you keep everyone? Another one, everybody can access logs. Shit, anybody can change a log. I talked earlier about a log being immutable. Well, if it's 777 stored in your system and anybody can get there, well, that's a problem, right? Relying entirely on manual processes for log governance. Like I have to manually have my junior engineers or admins every Friday night. They go and they rotate logs. That sounds stupid because we have log rotate. Go spend 20 minutes figuring out how log rotate works. And then on those nights, instead of doing a bunch of manual log rotates, you could just sit there and watch Netflix instead. You guys think I'm joking all the time about sitting at work all day and watching Netflix. I literally automate everything and just sit around. And like can be chat or whatever. I don't care, right? Storing every single type of log just in case it's needed. That's a problem too. That's what we call paralysis, analysis paralysis. Like it takes... We store everything and we just don't know what to do with it. Like it's too much. And then checking log integrity only when necessary. Log integrity should be validated as logs are written. And if logs are rotated off and stored somewhere, you should check some of the data as it goes with them. That's actually native to the cloud. That does that natively. Most of these tools also do it as well. I didn't really talk much about it, but if we send logs immutably, we need to make sure that they haven't been changed in any way. And that's what the integrity of a thing is, right? So anyways, understanding that's something you can read about. Again, all these things are always more stuff. And then this last thing is landscape.cncf, looking at observability and analysis. You say, Scott, I only have so much time. I don't want to be a Linux engineer. By the way, guys, I will never be like, get the hell out of our server. There's 4,000 other people here that want to do Linux. Get the F out. You don't want to do Linux all day. I don't care. If you want to be a site reliability engineer or DevOps, or you're just like a programmer hanging out, I don't care. But if you tell me, Scott, I want to do those things, but I want to do Linux a little bit, but I really want to be in this observability and analysis stuff. Where do I go spend my time? I would tell you, go to the Cloud Native Foundation, CNCF, right? Cloud Native Landscape, this thing, and go look at which ones you should look at. These are the things that if you put FluentD, like if somebody's asking for Kubernetes and you have like FluentD and Jaeger and Prometheus on your resume and you can speak to those things, I can promise you there's not a single, you couldn't find me a company out there that's doing Kubernetes, like forward thinking, doing Kubernetes early adoption curve, that's not using these 3. And I would almost argue that is not using all 3 of these 3. You'd have a hard time finding. I guarantee you won't find one that doesn't have at least one of the three. But my point is, you say, Scott, I have limited time. We all have limited time, right? We all only have so much time to do this stuff. This is where I would go spend my time. Learn Fluent D. I don't even know it that well because I don't do as much Kubernetes as I'd like, but I use a lot of Prometheus. I use Prometheus in big government systems now. Prometheus widely accepted, Loki not yet. It's weird. It's kind of like this weird thing. But anyways, all right. So that's the course, guys. That's unit 6. By the way, when we did it yesterday, I talked a little longer. It took us about an hour 40 minutes. Today it took us an hour and 25. But the labs, the logs, all the things are up there for you guys. And we'll look at the review again real quick. But what is a log? Immutable record. Should be protected. We saw some of those patterns around what we should be doing. Should have some integrity around it. As we go put it in there, we should know that nothing's changed. How do we use logs? We use them to review incidents and look for patterns of problems. You know, incidents are discrete actions that happen typically, like something happens, server falls over, we bring it back up. Solving incidents, getting to root cause analysis of problem behaviors or problem things that are happening, all that. We talked about common log elements. So again, timestamps, what server it's on, the process, and then a short message to let you go dig in more. Where do we store logs? We store them in a place on the server and rotate it so that we don't fill up the server, and then we get them off the server in real time. This could be, I couldn't bold this and make this big enough for this course. Like, this is the most important thing I can tell you. Get your logs off your server in real time. It minimizes all the other problems that happen with logs. And then how do we parse and look at logs? You know, we can do it at the command line, and then we can query with specific tools. All right. Excuse me. If you have questions, ask me down in the Discord. I'm going to go ahead and drop here. This will be up in the YouTube if anybody needs it, and I'll also add it to the playlist. But I appreciate you guys coming by, and I will see most of you, let's say, later on